All right, guys, so here is lesson 5.3. I will do the warm-up for you quick, although I'm sure you guys are more than capable of doing this, but just so that you can check your answers. So remember what I had said in the factoring lesson was that the first thing you want to do is make sure you... All right, so you guys had hopefully recognized this from last year when you were doing, Pythagorean theorem and other right triangle stuff, simplifying radicals, square roots, both exact and approximate. So the exact value is when you write it in simplest radical form, and then your approximate is when you actually either use your calculator or use what you know about perfect squares to estimate. So square root of 24 can be simplified as square root of 4 times the square root of 6. Square root of 4 is 2, so 2 square root 6. Square root of 24, so we know that square root of 25 is 5, so square root of 24 has got to be a little bit less than that. Since it's non-calculator, you can approximate to, say, 4.9-ish, somewhere around there. If you use your calculator, I think it's 4.89 something. 50 would be 5 root 2. Square root of 50 is just a little bit bigger than square root of 49, so we'll call it 7.1. 10 root 2. So now again, if we think about my perfect squares, the square root of 196 would be 14. So we'll call this, I don't know, say 14.2, 14.15, I don't know, approximating. 72 would be 6 root 2. Bigger than 64, but smaller than 81. So we'll call it, I don't know, 8.5-ish. And then 52. So 52, hold on, let me just check my answer. Yep, so 2 root 13. And then square root of 52. So 52 is a little bit bigger than 49, so 7.2. All right, so x-intercepts and the quadratic formula. So basically what we're doing here is we are using the quadratic formula to find the solutions or the roots for a quadratic. And what that will do for me is give me the x-intercepts. So as a refresher, here is my quadratic. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The a, the b, and the c are the coefficients and the constant of that quadratic equation that you're given. So when you're looking here at this example, so my a is 12, my b is 13, my c is negative 4, so it will be x equals negative 13 plus or minus the square root, 13 squared minus 4, 12, negative 4, all over 2 times 12. So now if this represented, so, y equals 12x squared plus 13x minus 4, if that represented the quadratic equation that I was trying to graph, say, and I wanted to find the x-intercepts. X-intercepts occur when y is 0, and so subbing in 0 for y and then solving for x would be the way to get those x-intercepts. And so that's what I'm kind of doing here when I use the quadratic formula. That's what I'm solving for. I'm finding points on the parabola itself. So now if I simplify here, negative 13 plus or minus 169 plus, ay Dios mío, 16 times 12, that's too big for me at 11:30 at night. 16 times 12 is 192, all over 24. So I have, let's see, 169 and 192. Negative 13 plus or minus the square root of 361 over 24. That is a perfect square, so x equals negative 13 plus or minus 19 over 24. So the plus or minus basically just says to me, hey, you've got two x-intercepts here. So if you do negative 13 plus 19, I get 6 over 24, or 1/4. And then if I do negative 13 minus 19, I get negative 32 over 24, which is negative 4/3. Now those values represent points, so that would be the point 1/4, comma 0, and negative 4/3, comma 0. So if you look here at this page, do not change the decimals, keep simplified radicals. We do that because those are exact measures, and so you want to make sure that you are careful. If you write these as approximate values, if you round these to decimals, what you've done is you've given me an approximate answer, and if you had to then go and use that solution in a different situation, then you're using an approximation, then my guess is you're going to have to approximate again. So you're just kind of affecting the exactness of the answer. And so you want to make sure that you kind of get in the habit of leaving things in simplified radical form unless otherwise indicated. Obviously, if you're graphing, you need to round, but it obviously makes your life easier in the long run if you can kind of go back and forth. Anyway, so we're looking here, so x equals negative b, so negative negative 6 would be positive 6, plus or minus the square root of b squared minus 4ac all over 2a. Quadratic formula is not incredibly difficult to memorize. You are going to have it memorized. You're not going to be given the quadratic formula in quizzes and tests and things like that. So please make sure you take some time to commit it to memory if you haven't already. You guys may have done that in 8th grade, I'm not sure. So in case you didn't already, then please do. So all I've done is just gone through and continued simplifying here. At this step, just be careful. Some of you, this won't be an issue for, and some of you are going to try and do something crazy like, cancel out these 2's or something nuts like that. That is not okay. You cannot do that. So what you need to do is divide basically both of these pieces by that denominator. So it would be 3 plus or minus root 5. All right, and then here I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 11 plus or minus, let's see, negative, right? Is this right? 30 and 4 is 120. Nope, positive 1. Silly me. Over 12. So x equals 11 plus 1 over 12, 11 minus 1 over 12, so 1, and 5/6. Now when we talk about the discriminant is only the part of the quadratic formula that's here in red. So forget the square root, just the b squared minus 4ac. And so when you use that b squared minus 4ac, what you are doing or telling yourself or figuring out, indicating, whatever the words are, I'm having trouble with words right now clearly, is you are determining the nature of the roots. And what does that mean? It means, talk to me about the x-intercepts. Are there 2 x-intercepts? Is there 1 x-intercept? Is there no x-intercepts? So when my discriminant is less than 0, so it's a negative number. Now again, I'm not doing the whole quadratic formula, just that red part. So b squared minus 4ac. So 9 minus 40 is negative 31. That means that I have no real roots, which means I have no x x-intercepts. So if you think about what a graph would look like, it might look like something like this. So that it's a parabola, the graph of this quadratic is a parabola, it just doesn't cross the x-intercept at all. Now for my next one, if it's greater than 0, so b squared minus 4ac, this tells me that I have two distinct real roots, which means I have two x-intercepts. Something else to note here, when your discriminant is greater than 0 and is a perfect square, what you have is two rational real roots. And then my last situation is when d equals 0. So if you're looking at this third example, b squared minus 4ac, that's not right. That's not what it's supposed to be. What was that supposed to be? Hold on, guys. Doesn't even work. Let's change this to a 6. All right, now that should work. B squared, goodness me, minus 4ac. Hey, that works now. I get 0. What that tells me is that I have one distinct real root. I have one x-intercept. Sometimes people say that this is a double root because it occurs twice. If you were to factor this x squared minus 6x plus 9, that would be x minus 3 squared. So there's two solutions. It's just that they happen to be both the same. Finding the vertex. So when we talk about finding the vertex, there's a couple ways that you can do it. You can certainly rewrite this in vertex form. So you can do y minus 8 equals x squared minus 6x. B divided by 2 squared, so add 9. Add 9. Y plus 1 equals x minus 3 squared. So 3, negative 1 is my vertex. Okay? Now, another way to think about this when you're talking about your vertex shortcut is if you think about your graph, your vertex in relation to your x-intercepts, your vertex is going to be equidistant between your x-intercepts. So if you can find your x-intercepts and then find the average or find the midpoint between them, you will have your x-intercept of your vertex. So let me show you. So if I were to factor this, and if it's factorable, factor it. If not, you're going to use your quadratic formula. It just kind of depends on the situation. This is factorable, x minus 4, x minus 2. So my x-intercepts, I don't know why I just wrote that, 4, 0, 2, 0. So the point that is equidistant, or the x value I should say, that is equidistant between 4 and 2 is 3. Once you know that your x is 3, if you were to sub into your original, (9 minus 18 plus 8), negative 1. And there's your 3. Negative 1. So that is a shortcut for you. You know, if you're asked to find your x-intercepts in your vertex, etc., It might be easier to just find your x-intercepts and then find the midpoint between them to help you find your vertex. All right, so we're doing a bunch of things here. I want to find the vertex, I want to find the x-intercepts, the y-intercepts, the axis of symmetry, the symmetry point, etc. So before I do anything, my C is my y-intercept. So let me start there. 0, -8. I don't want to have to work too hard if I don't have to. So now if I look, -8, factors of -8, whose sum is 2, so x plus 4, x minus 2, does that work? Yes, it does. So if I set that equal to 0, my x-intercepts are at -4, 0, and 2, 0. Now, from there, if I want my vertex is going to be equidistant between those two x values. So if I were to find the midpoint of them, my vertex is going to be at -1 some. So how do I find that something? Y equals -1 squared to -1, 8 would be -9. And then for your axis of symmetry, your axis of symmetry always passes through your vertex. X is -1 would be your axis of symmetry. Your symmetry point, so that symmetric point is that point that's equidistant from your vertex, and then your y-intercept, it's in line with your y-intercept. So that would be at -2, -8. And then you can certainly find more points if you like, but that is really pretty sufficient. So if I were to make a sketch of this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so if I'm at -1, -9, I'm down here. 0, -8, and -2, -8. And then for my x-intercepts, I'm at 2, and I'm at -4. And this is my sketch. Again, obviously, if I am using, graph paper and stuff like that, I'm going to have a much nicer sketch than this, but not bad for a quick hand-drawn sketch. Graph the following, label, etc. So, if you want to get some practice in, rewriting in vertex form, you certainly can do that. Add 3 to both sides, factor out a -2, plus 1, minus 2. So my vertex would be the point 1, -2. Nope, sorry, 1, -1. That's what I meant to say. Y-intercept is at the point 0, -3. Axis of symmetry is the line x is 1. My symmetric point, so I'm at 0, -3 is my y-intercept. 1, and then I would be at 2, -3. Now for my x-intercepts, what you can do is, because you already have this kind of written in such a way that it sort of lends itself to pretty easy solving, sub 0 in here. So I have a -1/2, x minus 1 squared. Now, if I square root this, eek, I can't square root this, okay, because I can't take the square root of a -1/2, can't take the square root of a negative at all. So what that tells me is that my graph itself is not going to cross the x-intercept at all. I'm sorry, the x-axis at all. So my x-intercepts, they have none. So let's graph that. 1, -1 is my vertex. 0, -3, and 2, -3. And then here's my axis of symmetry. And then there is my sketch. Okay, you could have determined your x-intercept situation. Remember using my discriminant. Whoa. So if you had wanted to, you could have done your b squared minus 4ac. And so that would have been minus 24, negative 8. So my discriminant is less than 0. So that tells me, hey, guess what? I have no real roots. I have imaginary roots or no x-intercepts. That's it. So here's homework. Answers are on here, of course. So please make sure that you are practicing. As I said before, use each other as a resource. Please feel free to email me if you need help, you need questions answered. Hopefully these lessons are pretty clear. Tricky to do at, all hours of the night. But hopefully if I get these on here for you, then at least you'll have a resource to look back at if you're having questions or you're confused or whatever. So good luck with the lessons. Make sure you're practicing. Let me know if you need help, and I will see you soon. Bye.